Hello, greetings from Raleigh, North Carolina. I am Rob Coyle, the Director of Sales at PCX Corporation. And today I thought it'd be helpful to share with you the process that we took to share our design files with the open community and to achieve receiving the open accepted moniker on our product. This is the 90 kW Modular Data Center Design Package submission. The Modular Data Center Group is a subgroup of the Data Center Facilities Group, and we submitted this design against previously contributed 90 kW modular specification. For this presentation, with the help of Jason Ball, our engineering manager at PCX Corporation, we put this together to outline the process, and hopefully it's helpful. The contribution was outlined in this way. The design package is for a 90 kW modular data center in accordance to the 90 kW modular data center specification contributed in February 2019 by Schneider Electric. This design package was contributed under the OWF CLA, and the PCX is requesting OCP accepted recognition from the IC. Ultimately, what are we doing? How are we going about it, and what are we seeking? The OWF CLA is a classification based on our membership, and one that is different may apply to you. The design package contains the following items: materials detailing the electrical design and composition, materials detailing the HVAC design and composition, a CAD generated system layout, and a bill of material. This is the overview of our product. It's our brand is the FLX Modular Data Center. It's our modular all-in-one modular data center family. This example is the 90 kW. It has hot aisle containment, power distribution, ATS, fire detection suppression system, optional UPS system. Cooling method for this design is DX in-row and LED overhead lighting. By the name, the IT load is up to 90 kW. And that's with internal UPS and DX in-row coolers of N+1 redundancy. The number of racks is 12 or 14, and that's if you decide to use a UPS, central UPS system or not. The average density would be 7.5 or 6.4, again, depending if you had 12 or 14 racks. The maximum density would be 12 kW per rack, and that's a constraint of the cooling system. Operating minimum maximum temperature would be -20 degrees Fahrenheit to 95 degrees Fahrenheit. The module size is 42 foot 2 inches by 11 foot 2 inches in width and 11 feet tall. The module weight is 40,000 pounds shipping and an estimated at 41,500 assembled. We outline all the product info. Input voltage of 480 volts, AC, 3-phase, common for us in the United States. How the main distribution is the voltage to the rack at 120 volts, the ampacity of our distribution panel, how we're accomplishing rack distribution, the UPS system we're using for design, 5 in-row coolers, the total cooling capacity of 104 kW, operating internal temperature of 64.5 to 85 degrees Fahrenheit. Not to say that you couldn't exceed these dimensions, it's just the basis of design we used for this product. Fire suppression and detection, again, optional. We designed it with a Novec inert gas, smoke heat detection, auto and manual actuation, and audible strobe alarms. The exits are 1 primary and 2 emergency ones that I'll show you in the layout on the next slide. Again, more details on the physical size of the enclosure and then the environmental external design. Here's the overview layout. On the bottom left-hand corner is the entrance. You can see the exit lights is that light gray rectangle and smaller rectangles that are to show emergency exit lights. On future drawings, later in the slide, you'll get a little more detail on the doors. But again, we have an electrical lobby that holds most of the power distribution and house electrical equipment. And then you have a sliding door to go into the cold aisle, and then there is a traditional hinge door to go into the hot aisle. As I said, here's a drawing that shows the doors a little more clearly. The main entrance, primary entrance, is the 42-inch wide door in the bottom left-hand corner. And then there's two emergency exits in both one in the hot aisle and one in the cold aisle. Internal, in the electrical lobby to the left, there's that hinge door towards the top of the drawing and a sliding door for entering the cold aisle. This is for containment issues. This could also be used as a security, where if you had maintenance and you wanted access to certain components in the electrical lobby that you don't want access for, certain employees or, certain clearances, again, you could isolate the hot aisle and cold aisle as well. It also helps with environmental by essentially creating a man trap in that area, and also, reducing dust exposure. These are the product info that we submitted in the design file. You're able to go to the Open Compute website and see these files. I'm just demonstrating you some of the items we did submit. Was the cooling pipe system piping diagram, our electrical one-line diagram, and then all of our structural drawings for the walls, the roof, and our base frame. We submitted a bill of material, which includes items to construct the module itself, components related to the IT equipment, and then the electrical and miscellaneous equipment, essentially to turn an enclosure into a data center environment. Part of the submission comes along with how you are meeting the OCP tenets. And we outlined that with this design, we're attempting to meet all four of them: efficiency, scalability, openness, and impact. Now, prefabricated modules allow for manufacturing and deployment of efficient systems, minimizes the amount of work and waste on site. And the basic design of the module is in row to reduce stranded capacity with hot aisle containment. Scalability. The design is for data centers with up to 14 racks. It scales well below that. You could easily not populate all 14 racks. And for customers who look for kind of the pay-as-you-grow solution, you could add additional modules. Your demands now are below 90 kW. You're anticipating growth, and in the future, adding additional modules at varying sizes would be easily added without occupying an entire building and only using a portion of it. The openness. The specification allows multiple vendors to bid on the same concept, giving users choice and supply chain redundancy. If we were working from a single specification or single design, it allows customers to purchase things competitively. It also allows for redundant sources. And we're now working on the things that differ in design that have actual value and performance characteristics, as opposed to less critical items that make each of these suppliers provide something different that performs the exact same function. And lastly, impact. This effort, and I would say the modular data center specification and all the work by all the contributing companies, is the industry's first attempt to standardize how prefabricated modular data centers are even described. If adopted and further developed, it'll vastly improve the efficiency in which customers and vendors specify modular data centers. Today, we often spend a lot of time defining what's in the modular data center, or what capacities it should have, or what functions it should have. And as we work from a more common place, and all the vendors and all the manufacturers and users can share their needs and experiences, we could get to strong solutions much quicker. So I'm proud to say that our design files were accepted by the incubation committee. They are live on the Open Compute project website. You click here on contributions, and then it would bring you to the listing of all the contributions in the OCP ecosystem. And under data center facility, you can find the modular data center specifications. And there's one for the 300 kW and 90 kW. Under the 90 kW specification, you can see the design file contributions, and PCX's files are in there for your use. Feel free to review them, use them in whichever way it benefits you. And then invite is to come join the Modular Data Center group. We're a subgroup of data center facility. If you're a modular data center manufacturer or a user or someone who's considering using one, or you're a component manufacturer that thinks that a modular data center would be a good home for your solution, we welcome you to come share with us, come learn with us, and really make this group even better. Here are the links for our modular data center 90 kW. Part of the requirements is that you have a product on a design contribution, is that you have a product readily available. We do. You can go to that website, learn more about it. If you're interested in ordering one or just have questions about it, you can access it there. You can join the Modular Data Center mailing list. And then the links I showed you, you can go to the OCP website and navigate that way. Here's the direct links for the design files and the specification in which the design files were created. Thank you for joining my session, and I hope this information will be helpful to you in your future contributions.
Hey everybody, thanks for joining this session on our modular data center design package submission. I haven't seen any questions come through just yet, but on the tab there in chat or the Q&A, feel free to comment or ask any questions that I could respond to live. We had presented this information. Jason Ball and I, our engineering manager here at PCX, had put this information together to show what we submitted and to give the community more access to our actual design contribution. But the other component of this presentation was I wanted to walk through a little bit of what that submission process looks like. We mentioned on previous calls that the modular data center lives somewhere between facility and product. So where a lot of the contribution documentation is aimed at server technology and basically off-the-shelf items that are replicated identical in volume, modular data centers have some adaptation required for local jurisdictions or certain country regulations or other criteria you're trying to meet. So there is some flexibility, but what criteria for a design submission both meets the specification and meets the tenet of the OCP in that we're sharing an open design. There's no secret sauce of how to do this, and really operating in the benefit of the community to come up with a more common place to start from with a modular data center. And I do have a couple things here. Mark DeLillo asked, I may have missed it, but is the all-in-one an external unit? And if so, can different exteriors be used? Yes, the design of the specification and our design contribution is intended to be exterior. It has criteria that it meets for that specification, but as I mentioned, certain jurisdictions or certain countries may have different varying requirements. This is to meet the specification requirements. So the exterior could be changed if a local municipality has a color or a material requirement on the exterior, maybe to blend in with surroundings, or maybe to meet a certain insulation requirement. So this design easily allows that. It uses a tubular steel structure for its rigidity, and then we have our base design for insulating material, but that could be easily modified. Brevin added here, are the electrical and cooling design vendor agnostic? Yes, it was actually very easy for PCX to transition into the OCP community because everything we do is vendor agnostic. We want the best of breed solution for the requirement, whether it's electrical, cooling, whatever it may be. So in this design, we submitted a bill of material with a specific vendor selected so that to demonstrate that there's a part number for each of the components and someone else could go out and replicate it. But the design allows for any vendor to be integrated in the solution as long as it meets the criteria of the specification. Thanks for both those questions. Does anybody else have anything on either the 90 kW design submission, what steps to take for understanding how to contribute any sort of design for either the modular data center group or data center facility? Jamal Kayer has a question here. Thanks. Have you considered liquid immersion cooling in your design? Yes, it actually has been a discussion point in the modular data center group about liquid immersion cooling. Certainly there's some inherent advantages there for footprint and maintenance and components required. This specification did not really include liquid immersion cooling as part of that requirement, but we would certainly welcome that discussion on a new specification or an adaptation of the existing specification. And we could certainly look at including liquid immersion into a modular data center design. Being vendor agnostic and the modularity of this design, it would not be very difficult to change the structural components in the base frame and change the interior arrangement to accommodate liquid immersion cooling. I don't believe so. I haven't done it personally, but from what I understand about it, and it's the liquid immersion tanks modularity in a traditional facility would all apply here. So please feel free to reach out to me or join one of our calls. We can continue that discussion. Mark DeLillo asks, what would the deployment time be for this? All manufacturers are going to vary a little bit based on their manufacturing capacity. We're seeing with completed designs the average of 12 to 16 weeks potentially on delivery. One of the constraints is having equipment on hand. Thankfully, in a modular design, there's a lot of processes that can be parallel. So we can order equipment in advance. We can be integrating switchboard, UPS, those items while the construction of the module is being performed, and then they can meet each other in the assembly line to take advantage of concurrent processes. So it varies, but if with an existing design, it can go much quicker. So with our existing design, we don't have to go through all the requirements and the time to actually do the engineering. This is ready to go. At this point, it would just need the shop drawings reviewed, make sure it meets the municipality requirements, and we could start manufacturing. Sami Faith, what is the power efficiency level, gold, platinum, or titanium? I'm not familiar with the level requirement. Feel free to type in more under what authority is measuring. I mean, you have tier requirements, efficiency requirements that, depending on what you're attributing it to, will vary. I think the biggest driver here, as far as a modular data center, would be the efficiency of the cooling and the associated electrical hardware. And so that's going to vary from a low cost, low efficiency to a higher cost, high efficiency, right? And it'd be the balance of OpEx and CapEx in a decision. Being vendor agnostic and being modular and that this is open, there's a lot of flexibility to make sure that the efficiency levels are met for the requirement. But there's not a standard power efficiency level that we aimed for in this design. In our design contributions, you can see our efficiency goals and prototypical designs and the locations we chose to meet PUE. But then we can have a more detailed discussion about what type of equipment's going inside to meet those. Great, thanks for the feedback. If we were in a presentation hall, I could see a reaction and a nodding of you saying yes or no, or I'm way off track. So speaking into a computer screen without being able to see all of you is a little different, but we're making it work. All right, well, we have just a couple more minutes. I'll let, I still see that there's still a lot of people in the room, so if anybody has any more questions, I'll hang out for a little while here, see if any more come through before we close this session. All right, well, I think we got the questions answered. Thank you again for joining the session. If I can help you join the Modular Data Center group or Data Center Facility group, or just get more involved in general in OCP, please feel free to reach out to me. If I can't answer your question, I can put you in contact with the person who can. So thanks again, and enjoy the rest of the virtual summit.